we continue here under lesson 3, conditional statements, with this lesson. And indeed, students at the Helsinki University, we recommend that you use the CSC notebooks. Others can launch the interactive version of this lesson over at Binder. So I'll flip over to my CSC notebooks, lesson 3, conditional statements. So you should see the same thing on your own computer there. And if you have any problems, please post to the chat. So maybe Dave can react to any urgent technical issues. So conditional statements are all about making decisions and choices in our code. So if something, then do something else, do something else. So basically, we analyze some conditions, and based on these conditions, we take actions, we run certain parts of the code. We could make analytical choices. If we are running out of coffee, go and buy new coffee, or reclassify the values based on certain conditions. And these types of situations, we will often need to make some decisions. And in this case, the decisions are quite easy. So either a condition is true or then it is false. So we are operating with Boolean values. That is now a new data type that we'll be dealing with during this lesson. All right, so let's start with an example. You should see this code block readily filled in. So it's nice to talk about the weather, especially in September in Helsinki. And we could see what kind of temperatures are hot or not hot. So for a Finnish person, Celsius degrees may be greater than 25, would be already quite hot. And then anything less than that is quite agreeable. So if we start here, we define a variable temperature that gets the value 17 integer. We can check that if the temperature is greater than 25, then we tell that it is hot. And in all other cases, so if it's not greater than 25, then we tell that it is not hot. And you can run this line of code and see what happens. So Python runs everything line by line, starting from here. So defines the variable, then it checks this condition. But now here, as our temperature is not greater than 25, it doesn't execute the code related to the if statement, but instead it executes the else statement. So this is the very basic example of a conditional statement using the if, a single if statement. And a couple of observations. So a bit similarly as with for loops. So we start with a statement. So there's the word if. Then we have a condition. So here we are using the greater than operator. We can also have other types of comparative operators that we'll have a look in a bit. And then again, there is this colon like we had in the for loop. So we indicate that after this comes the related code set that would be executed if the condition is true. And then also we have this indentation before the code block. So there is four spaces in there, likewise with the else statement. And same as what Dave showed. So if we wouldn't have this indentation, then we would get an indentation error in there. So Python forces us to write readable code also with the conditional statements. Okay, so that's quite logical. You could next try to modify the code a bit. I'm now selecting everything and copy pasting it here. So if you try to modify something in here now so that we would actually end up running this line of code. So you should update the value of temperature to a so-called hot temperature so that this condition becomes true. And just to see who are following, I'm not sure if these are now the old, I'll clear the check marks. So if you please put a green check mark once you manage to get the first print statement as output. Okay, I have now roughly half of you at least have indicated that you are following. So maybe I'll go ahead and show what was the point here. So without modifying the conditions, I can update the value of temperature to, let's say, 30. That would be quite a nice temperature in decimal degrees, Celsius degrees in Finland. So in this case, when the value of the variable temperature equals to 30, so in other words, it is greater than 25, then this line of code gets executed. And in that case, the else statement isn't. So Python looks for the if statement, and if it's true, then it executes it. If the if statement wasn't true, then the alternative gets executed. And you can also write a conditional statement without else. In some cases, that might be sufficient. So you can now, for example, copy this example, type it in here and see what happens. See what happens if we don't have the else statement in there. I'll start with the first temperature value, 17. Well, if temperature is greater than 25, colon, print okay. Oops. And then I get a typo and not then. Oh. So in this case, again, Python checks, was the if statement true? If not, do nothing, look for an else statement. There's no else statement, so nothing gets printed out. If I would then, again, use a value that meets the condition, so the condition is true, so then I get the output in here. So indeed, the conditional statements check if our conditions are true or false, and then acts accordingly. Okay, so let's move on to another example, which is readily filled in here. Let's continue to talk about the weather. Again, so we set weather to rain. So this is now a string variable, and we can also do these conditions using string variables. And we want to know what to wear according to the rain weather outside. So if weather is rainy, so if weather equals to rain, We want the program to tell us to wear a raincoat, and if it's not rainy, we won't need a raincoat, quite simply. And here, if we want to test if something equals to a value or is equal to a value, we use kind of this double equal sign operator to test if the value is true. Let's run this. So what happens in here is that on the first line, we assign the value to the variable weather equals rain, and then we test if weather equals to rain using this comparative operator. So that's quite straightforward. And there's again another note about the syntax. So indeed, if we don't have the indentation in here, we'll get a syntax error, indentation error. Another common error is syntax error. So if we don't have this colon, I get a syntax error. And often when looking at these error messages, you even see that the little arrow is pointing to the line. So we see that on line 3, so 1, 2, 3, at this point, there is some kind of syntax error. Oh, I forgot the little dots, and then it works. So now that we start to write a bit longer code blocks, you might get errors when developing your code. So then always read carefully the error message. It often tells you what's wrong, and it's often about these little things. Still about this operator. So if I would have it like this, I get another syntax error. So Python refuses to replace or reassign value to a variable in the conditional statement. Okay, so next stop, similarly as with for loops, so we can have multiple lines of code related to the conditional statement. So you could, for example, copy this piece of code under here and give some additional instructions in case of a rainy weather. So try to modify the code above so that it would print 2 lines of instructions in case weather equals to rain. So if you want, you can take this code block, paste it there, and try to modify the code. Okay. So I have again roughly half of the participants who have said that they are ready to go. So according to the instruction, if I want to add lines of code, I would go here under the if statement. And if I press enter at this point, Jupyter Lab already automatically puts the cursor so that it's indented in the correct place. And if I write here print quotation marks where rain boots and execute, so indeed weather equals to rain, so the code continues here and these lines are executed. So you could add however many lines of code you want under the if statement, under the condition. And likewise, also the else statement can span multiple lines. All right, so we saw 2 examples of these comparison operators. We used the greater than and equal to. So there's a set of other operators listed in here in this table. So less than or equal to, greater than or equal to, greater than, and then not equal is exclamation mark, and then the equal sign. So especially when dealing with threshold values, it's good to pay attention. Is it this less than or equal to, greater than or equal to? So are we including the threshold value in the condition or not? So for example, if creating classification for thematic maps, if dealing with some other statistical data or classification. So it's good to pay attention not to double count values in different classes, for example, and to be aware of, is it like equal, does number 3.0 belong to the condition or not? This you will need to pay attention to in the exercise this week, I think. All right, so then Boolean values. So this is one of the data types that we are using in Python. Basically, two possible values, true or false. And these are these reserved words, capital true, T true, and capital F for false. So you can't, for example, have a variable that's called true because that's reserved for these Boolean values. So we have some variables in memory at this point. We have temperature. Oh, currently the value is 30. In my code, you might have it as something else. So we could check, and the condition we used was greater than 25. So this condition returns a Boolean value, true or false, based on the condition. So we have the current value of the variable, then the operator, and then another part of the condition in here. So then, of course, if I would switch the sign here, let's say, is temperature smaller than 25? So then we that is false with the current value, and then that would be the condition. Then we have another variable called weather. Check the value, and does it equal to rain? True, yes it does. Maybe we might have then other conditions for snowy or icy or sunny. So then in those cases, the test would fail. Maybe just to elaborate, I don't think we have this on the website, but then if I would now, I'll just demonstrate this here. So this whole block in here, if I check what is the data type, so Python tells me that the data type of this block is a Boolean value. So that is important to understand when then constructing the conditions for if statements. All right. Okay, so let's add in a bit of complexity. So we can also link several conditions using this kind of if something, then else if something. So if the first if is not true, we can test another scenario using this elif statement. And indeed, Python checks the elif statement likewise as with the else statement only if the previous conditions were false. So reading from the top to the bottom, if previous if or elif statements were false, then Python checks the following one. Okay, so this code block shouldn't be there. So let's take another example and take a little minus temperature that we might experience that in Helsinki, let's say, in the coming month or so. So let's check using if and elif statements what information can we provide based on the temperature value. So first, if temperature is greater than 0, so that it's not freezing, we could tell that it's above freezing. So the first condition is always then if. I'll just copy temperature because I apparently have trouble typing it in while speaking. So if temperature is greater than 0, so notice we exclude 0 from the condition, the dots, then print is above 3. I already at this point, I'm not yet done with the code, but I just run these 2 lines to check that I haven't yet created any syntax errors. So that's also a good practice when you're developing code. Write something, write like a minimum block, test it, then add complexity. Okay, so we see nothing as output because our temperature value is below 0. So let's add another condition. So else if temperature is exactly 0, print is freezing. So elif then temperature is exactly 0, so equals to, and here was the double equal sign 0. Print is freezing. Okay, yet nothing because our temperature value -3 doesn't meet any of these conditions. And then finally, else. So in case these above if statements were false, then the code ends up in here. Print is below freezing. Okay, so quite logically, we get the final print statement displayed in here. And we could, of course, make this a bit more informative by also printing out the value that we're testing. So we can add this temperature in our print statement. So in here, for example, comma is below freezing. And then I can copy this to all of these scenarios. So if we would be testing some other value, we would see it printed on the screen with the text. And of course, then you could add, is it -3 kelvins or Fahrenheit or degrees Celsius? So -3 degrees Celsius is below freezing. And quite logically, if you would want, or if you would need, you could have multiple elif statements before the final else. All right. Okay, so let's take a little pause so that you need to read a bit of code and think about the logics and the conditions. So there is a little code block in this orange box with some values. So yesterday is 14. We can assume that these are Celsius degrees temperatures. Today is 10 degrees and tomorrow is 13. These might be actually even quite right. So your task would be to, by reading the code, see which of the letters A, B, C, or D would be printed on the screen based on these conditions. So take a little moment, read through the code and try to think which line gets printed. And when you're done with that, maybe again, now I'm clearing the check mark. So if you already pressed it, please do it again. And we have this question up in the poll over here. All right, let's see what the poll says. Okay, which of the letters AD would be printed to the screen? We have some votes for B and C, B and D. Only B gets majority of the votes, only C and some other combination. So let's see how it goes. Okay, so we had yesterday equals 14, today equals 10, tomorrow equals 13. If yesterday is smaller than or equal to today, so is 14 smaller than or equal to 10? That's false, so we skip this first if. Then else if today, so today is 10, is not equal to tomorrow, which is 13. So 10 is not equal to 13. That is true. So we would print B, skip the rest, and proceed. That's my logic. Let's test if I'm right. And I think majority of you guys were also thinking that that's the solution, that only B would be printed. So that's true. So indeed, even if then yesterday is greater than tomorrow, so this condition is also true. This condition would also be true, actually. Today equals to today. So when Python meets in this kind of chain of if and elif conditions, so when Python meets a true condition, it executes that set of code and then skips the rest. Okay? Maybe one modification if we would do this, which now looks a bit ugly. So if we change these as, well, maybe all of these as if statements. So then we would get all the prints that are related to a condition that is true. So actually, all of the conditions except for the first one are true. But as we had this elif structure, then they are kind of relational to each other. So only if the previous if statements were false, then the following ones are checked. Otherwise, Python skips those rows of codes. So this is related to the control flow, making decisions which part of the code are run, which are not. Okay. Moving on, we can also add some complexity to the conditions, so we can combine multiple conditions. So using this basic logics and kind of set logics. So if we have true and true, that equals to true. If we have true and false, that is not true because both are not true. But if we use the or operator, so if we had true or false, or one condition and another condition, and at least one of those is true, then the whole combined condition is true. Okay, this is maybe clearest if you test a bit with some actual values. So we can run these examples and try to read them true. So if 1 is greater than 0, so this is true, right? And if -1 is greater than 0, so this is false. So this line won't get executed. Instead, we ended up in here. At least one part is not true. So with this AND operator, we mean that we want two conditions to be true. So for example, if we are running out of coffee and there is no coffee in the storage, then go to the store. So these kind of double conditions. But if coffee was only running out from the cupboard, then we can go to the storage if there was some coffee. I don't know, maybe I need to have a sip of my coffee to come up with better examples. If then we would switch this sign in here, so now we have two conditions that are true, then we end up in this line. Both parts are true, right? But if this seems a bit already complicated, maybe good to test with different values, combine different options. So there's always a logical reason for in which the code works. And if it's not logical, then Python will give you an error that there's something, some syntax error or some logical error in the condition. Okay, and then with the OR operator, if one of these two conditions is true, then this line would get printed. But then again, if we make it so let's see, we have now, this is true, this is not true. So if we change it so that both of these are, sorry, this is false and this is true, yep. So if both of them are false, then nothing happens because we don't have the else statement in there. Okay. And just to note, especially, well, already when we are using pandas in week 5, we might use these bitwise operators instead of the words and or. We will then need to chain these conditions using this @ sign or then this kind of whatever it's called, straight line. I bet it has some official name. But yeah, so if Python bugs you about the syntax, then it might be later on related to just the different ways of indicating this combination. Okay, but let's make it more clear with an example. So I don't know if you have checked the weather, but if you haven't, let's check it together. So this is now the weather forecast for Helsinki for this week. So today is the 16th of September 2020. So weather today will be still quite all right in Helsinki, but tomorrow latest there's the storm coming. So winds will be gusting up to, well, 26. That has increased since yesterday evening. So it will be very windy and also rainy tomorrow. And it actually really might be a good idea to stay at home, especially tomorrow afternoon. So not a good biking weather. And you can see that FMI has here some conditional statement going on. So if, I think they have it here, that if wind is greater than, equal to or greater than 9, then this arrow ball turns blue to make it more visible to the reader. So inspired by the nice weather this week, let's write some combined conditions. So there's 2 variables readily defined. So we still want to check if weather equals to rain. And then I have another numerical or integer variable, wind speed, which I have now set to 9, which is probably the, well, today it might be 9 meters per second, tomorrow even more, even the average wind speed. So your task would be now to spend some moments to write a conditional statement that checks that if weather equals to rain, or if wind is greater than, let's say, 8 meters per second, which is the limit for navakka tuuli. It's not yet storm, but it's already quite a lot. And if you're feeling comfortable, you might want to stay at home, even if it's a fresh breeze, and even more so if it would be stormy. But you can use this 8 meters per second as the threshold. So if weather equals to rain, or if wind is greater than 8 meters per second, print stay at home, and else print go out and enjoy the weather. So that might be the situation over the weekend. All right, so I let you think about this for a couple of minutes. And if you're totally confused, you can let us know. I'll show the solution in a bit. Okay, so I'll show my version of it. So again, if statement starts with the word if, then we put in the condition. So if weather equals to rain, or we could also have and, so if we want to restrict it so that it has to be rainy and windy, but I think both, like if it's rainy, don't go out, if it's windy, don't go out, and even more so if both of these are true, but it is enough then if either of these conditions is true. Speed greater than 8 was the threshold I suggested. That's the end. After the dots, enter indentation, then print stay at home. And then in the opposite scenario, so if the condition is not met, then print go out and enjoy the weather. So this might be the case over the weekend, might be very nice autumn colors to go out and enjoy after the storm. Okay, let's see. Now I wrote quite a few lines without testing, so everything works. Maybe a couple of things to note. I'm actually not sure would this work without the brackets. Let's test. Oops. Yes, it is. It doesn't require the brackets, but I would recommend. Dave can disagree if he wants, but I would recommend using the brackets. It makes it more clear where is one condition, and actually later on when we are working with pandas, I think then you will get a syntax error if you haven't kind of surrounded your condition or kind of subcondition with the brackets. Correct me if I'm wrong, but I recommend doing it like this. Also for the readability of the code, that was one observation. Maybe another observation related to kind of formatting the code, that you can see that I have here a space around this operator, also a space in here, and spaces in here. The code would work without these spaces, but then it's according to the good coding practices we will talk shortly about. So it's good to surround these certain operators with a space, and then in certain other situations it's good not to have the space in there, but we'll come back to that. And if you have any questions, please ask. So indeed, let's say it would be still, if we get the gusty wind of 26 meters per second, then definitely please stay at home, but already now with this kind of moderate wind, it might be just nicer to be at home. But then if it would be, let's say, still, if it's rainy, but the wind is not so bad, still we're asked to stay at home. But then if it's sunny and not so much wind speed, so then we can go out and enjoy the weather. And you can imagine you could then add here with elif statements, for example, alternative instructions or alerts for different wind categories. So I think the official limit for a storm, at least in Finland, is 10 point something, which will be the case tomorrow. So stay safe. Okay, I see no questions. We still have a final code block related to this lesson. So how to put together for loops and conditional statements. So then it already starts to be quite powerful in terms of automating processes, repeating things, making decisions, controlling the flow of the code. So let's take an example from there. So we have a list of temperatures 0, 12, 17, 28, 30. And coming back to the first example in this lesson, let's tell to the user if these temperatures are hot or not. Okay, so if you haven't forgotten, if we want to iterate over the list of values, so the temperature list, we can do a for loop. So we don't have to take each value individually from the list and test those. So for, I'll now write temp to be short. For temp in temperatures, do something. Okay, and we could, of course, as we did before, so you can print temp. So print the values in the list. I run this, it works. I have no syntax errors at this point. It's good, but if I want to test if temperature is greater than something for each temperature, so then I can add a new line before the print statement and insert my conditional statement. So if temp is greater than 25 dots, then print. And as you remember, with the for loop, we need the indentation. So also with the if statement, we still need the indentation. So now it's already, by looking at the code, you can see the different levels going on in there. I can run this and test it. Okay, it works. It prints me, goes through the list, checks if 0 is greater than 25. It's not, nothing happens. 12, if 12 is greater than 25, nothing happens. Then 17 gets assigned to temp. Again, the condition is false. But then when temp gets the value of 28, then this condition is equals to true. And then the value gets printed. Same for 30. And then, of course, we can make this more informative, add some text to the print statement. So Celsius degrees is hot. Okay, so that happens 2 times because it goes through the for loops 5 times. So equal number of times as there are items in the list. So the length of the list, but then only 2 times out of 5, the condition is met. And then we can, for the other cases, so else print temp how it is with those values. So then now in the first round, temp gets value of 0, the if statement is false, so then the else statement gets executed. And you will get to practice this in the exercise with a bit longer blocks of code. All right, so that was the very basics of conditional statements: if, elif, else, Boolean values, true and false. We learned how to combine conditions, so true and true, true or false, these sorts of things. And finally, to combine the for loop with the conditional statement to make repeat and make decisions efficiently. So if you have any questions, I'm happy to answer. Otherwise, I'll stop sharing my screen and pass it over to Dave for a short while.
Okay, let's continue here, and give me just a second to get myself organized. And I can start sharing my screen again. All right, so we have, I guess, 2 things left in the lesson for for today. I guess it's kind of one thing left in the lesson, and one thing that is sort of a preview for the exercise. So yeah, we've now heard about for loops and conditional statements, and you've seen for both of those that Python imposes some restrictions in terms of how you can format the code whenever you have a for loop or a conditional statement, in the sense that you have to have indentation underneath these statements in order for the code to work and to not get one of these indentation errors. And our good coding practice for this week, our good coding practice number 3, relates to the idea of writing readable code. So if you're wondering why it is that Python has this, it's basically kind of a design principle that makes you indent your code underneath a for loop or a conditional statement of some form, it has to do basically with code readability. And when we're doing these very simple statements where we have one condition and maybe 1 or 2 lines of code that would be run for that condition, it's not necessarily that challenging to see what the code is doing. But when you start adding more and more to what your programs are doing, you have multiple conditions, for loops within a conditional statement, and things like this, it gets a little bit harder to read, especially if there's no consistency in terms of indenting the code. So that's what our good coding practice is about this week. And I'm just going to take you through a couple things because there's quite a bit of detailed material here, and maybe you want to look through this on your own time. But yeah, the first thing here is just about the concept in principle between working code and readable code. So you could certainly write all of your Python programs if you wanted to. You could write them out as a single long line with semicolons or other ways of breaking the lines. And it would still potentially work. The indentation could get challenging, but you could basically write for certain kinds of programs one single long line containing all of the code, but it's not very readable. And part of what you're doing when you're writing code is writing code that both you yourself could understand, but also other people could look at and quickly understand. So that's the basic distinction that we're making here, and that's where this PEP 8 style guide comes in. So this is something that's generated by the people who've written the Python programming language, and it's essentially some guidelines for how you should be writing your code when you're writing code using the Python language. It doesn't necessarily mean that these are harsh and in rules that if you break them, someone's going to come find your GitHub repository and reprimand you for being a bad, not stylish Python programmer or whatever. But it does mean that there are some guidelines that are helpful for making your code easier for you and other people to read. So this includes things like maximum line length. So the guide suggests that you shouldn't have lines that exceed 79 characters. Lines that are too long might not be able to be easily seen in a text editor, for example, or in your Jupyter notebook. So it suggests different ways that you can break the lines. So you can see, for instance, here in the example of a list of US cities, that for a list, you're actually able to spread the list onto 2 lines without even having a character there, as long as you break the line at the comma between items in the list. In other cases, you can have other characters like a backslash that would allow you to break lines that maybe have a long character string, for example. Indentation, as we have seen, the guidelines here suggest using 4 spaces at the indentation level, and that just helps make the code more readable by indenting things that are part of some condition or for loop statement. So you can see some examples here about how to deal with indentation and stylistically how to end up with readable code. They also talk about white space. So this is the space in between characters in your code and binary operators. So when you have things like an assignment where you say I equals 1, or I equals I plus 1, or I plus equals 1, we haven't dealt with this one explicitly yet, but it's basically a way of saying shorthand version of I equals I plus 1 is to say I plus equals 1. We'll add the value of 1 to the value of I and store it. And the suggestion here is that you should always have 1 space on either side of these characters. So this makes it more readable. which means that you shouldn't have something like I equals 1 with no spaces, I equals I plus 1 with no spaces, or I space plus equals 1 with no space. That's also not suggested. Now, you can, in some cases, do that if you have things within parentheses. Sometimes it's easier to put the values without a space, just to indicate that that's kind of groups things together visually so you can see what is happening within the parentheses. Sometimes you'll also see this in functions, which we'll get to in another week or so. And that, you know, although it's good to have spaces between things, they also suggest that you should not have extraneous white space. So although the code will run if you put a space in between the print statement and the parentheses, the print function rather shouldn't have a space there. So it's suggested not to do that. And in addition, rather than using semicolons to break lines, it's suggested that you put each separate statement on a separate line. We got a little bit of a typo here. So this would be a good example of a place where we could make a pull request to fix this, this heading here about the length being misspelled. So it's true. I mean, as you know, you're balancing things a little bit when you make your code more readable versus the code length. Sometimes making the code more readable also means that it makes things a bit longer. And there's an example shown here for list comprehensions. This is basically a shorthand way of writing for loops. And this is sort of a stylistic thing. People that are more experienced in looking at Python code will understand that this code here, squares, will create a list that is going to be equal to the value of x squared for every value of x in range 10. That's the same thing that happens above on 3 lines, but can be done on a single line using list comprehensions. And depending on what you're doing, whether you think it's understandable, this is actually not that hard to understand, but it would not be familiar, for instance, to most of you who have only seen for loops for maybe an hour or a little more, hour and a half or so of experience using for loops. Probably you're going to have a little bit of trouble to understand this list comprehension. So there is a balance. The point is that you can go to the PEP 8 documentation online. You can find it here, this PEP 8 style guide for Python code, and you'll find all kinds of suggestions there for how to style your code to make it easy to read and compliant with the sort of guidelines for how other Python programmers are going to be writing their programs. I think that's probably covering it for the PEP 8 style guide. I don't suppose anyone has any questions, but maybe while we switch over to Walko giving an introduction to exercise number 3, if you do have any questions, you can feel free to ask them now. Seems like no. So maybe, Walko, do you want to give an introduction to this exercise?
Yep, sure. Just in a second. There we go. You should see my screen. Okay, so exercise 3, it's already published there. My mouse has resigned, so I have to scroll from the trackpad. Basically, same as last week's. So deadline would be by the start of the next lesson. So by next week's Wednesday at 9 a.m. And again, we ask you to create your own copy of the exercise by accepting the GitHub Classroom assignment. Over here, I'll demonstrate it on the fly. There we go. And maybe the first note, so we will continue pair programming this week. And you can see the motivation for that in week 2 lesson. So we have notified the pairs in Slack in the general channel, and based on the feedback today, things have gone well. But if you have some issues or if you haven't been able to contact your pair, you could maybe let us know, me and Dave, or then in the list you can see the assistant that will check your exercises, so you can also contact them directly. So we might have to indeed regroup some of you after this first week in case some of the students are not actively participating. But glad to hear that it's been going well. So exercise 3 is all about for loops and conditional statements that we discussed today. There's something in the chat. Maybe Dave can see what was there in the chat. So we have 3 problems. So this is already a bit more extensive as an exercise as compared to last week. And I'll explain these quite briefly. All of these problems have some kind of a list you're working with, and then you'll be using for loops and conditional statements to process that list. So in the first one, we'll be kind of simulating this batch processing of files, which will be a useful skill, especially those continuing with AutoGIS. So we often have a folder full of files. We need to somehow access the files, list file names, and so on. So this first exercise is all about playing with file names. We are not yet interacting with real data. So that's problem 1. In problem 2, we have a list of temperatures that you will then have to go through, write some conditional statements, and then classify the values based on that. So there's a list of temperatures, floating point values, and here please pay attention to the kind of threshold values. So do you have the equal to sign or not? And then the third problem is about locations. So we have some lists of coordinates that are located in Finland. I think there should be, I think we're again missing the image. Maybe I'll show it from here because it's nicer. Sorry about that. I think it should be visible in here. Maybe a side note, if you're having problems with notebooks over at GitHub, don't worry. If you can see your latest commit message, everything should be all right. There was a question about that. So yes, so in the third problem, we have some locations, so coordinates in lists, and you have to classify the coordinate pairs into new lists using for loops and conditional statements. So this is quite a nice, actually there's a third list with then station names. Okay, so 3 problems, and then in addition we have a 4th problem which is totally optional, but it's quite fun and also a good way to really test your understanding about for loops and index values. So in the 4th problem, your task is to create a piece of code that automatically creates this kind of star flag on the screen. And you're also welcome to ask questions about this exercise in the exercise sessions then tomorrow, Thursday, and then after tomorrow on Friday. So 1, 2, 3 problems are kind of compulsory, and then this 4th problem is optional. And just to remind you, so during this pair programming, you're supposed to somehow interact with your pair. Hopefully you are able to work together during the exercise sessions or find some other time to work together. If that's possible, somebody said that it is a challenge to find a common time. So then it's also okay to work on your own copy, and then you can share your file or share a print screen, agree with your partner about the solution. And this week, especially, start to pay attention to the good coding practices. So variable names, code comments, and the markdown explanations. And then finally, this PEP 8 style guide. So are the indentations there? Do you have this white space? Do you have long lines of code? So already when working in the pair, try to comment and correct the style of the code so that it's readable to a human being as well. Okay. All right. If you have some questions, I'll be available here after the class for some while. You can send me a Slack message, or probably Dave as well, and then indeed go to the exercise sessions. And if you have some questions, post them on Slack. So we've been receiving some emails. That's fine as well, but we would prefer to get any questions and messages via Slack, because then it's we can find everything in the right place and your message doesn't accidentally get lost in the email inbox. All right. So that's it for today. Dave, do you have something to add?
Nope, nothing really to add from me. Just good luck. And if you have questions, as Volko has already noted, about the for loops or conditional statements, post them in Slack and one of us will get back to you promptly in most cases. Yeah, I think that's it. Next week, I think we're on to looking at functions, if I'm not mistaken. And as mentioned, the exercises will start taking a little bit more time, so it is good to take a look at them early on and plan ahead. Otherwise, I think we'll see you next week. Okay, yeah. Have fun and yeah, be safe in the storm. Sure. All right, bye-bye.